Hey, good morning. Good afternoon, good evening. What am I saying?
Yeah, no, that's
Yeah, I was. How are you doing?
good. Good. You?
I'm still sick. That coughing is not gone yet. I
That's not good.
got the virus.
Did you survive the AWS outage today?
I know. Yes. Yeah, everybody's talking about that. Just that. In fact, the outage is probably gone. I think it's not outage anymore. For some buckets, still not accessible, but most of the buckets have recovered. And the
Yeah.
funny thing is, even Amazon's own marketing site, which stores content in the buckets, was down.
Yeah.
Yeah. So, in fact, the idea that we have today is to discuss variety of blueprints of architecture. That particular site, which is this site here. I'm going to share my screen. Sharing my screen right now, and this Amazon site, which is about architecture. Where did that go? AWS architecture. This site had a bunch of items that we have intended to discuss today. They were not accessible. Just specifically for today. Like I was planning to go through all these things, all these examples of illustrations that they have here. That was my agenda item for today. It still is, by the way, but I was just attempting to click open any of these guys and it would not open.
Oh.
That was because these things, the PDF files here, are stored in a bucket. In this bucket, actually, Architecture Center bucket in US East 1. So if you talk about US East 1 outage, that's where it is mostly.
Right.
So there is lots of news about it. Resolved. That thing is resolved. They're claiming it resolved, which is nice. At least the claim is resolved. There are issues might affect your AWS. 23 issues were resolved, and all of these seems to have closed, which seems that they have, basically succeeded in getting their act together, which is nice. Open issues 22. Why still open? Yeah, so we'll occasionally run into this increased error rates issue as we go along, but we know that it's happening, and so that's how life is. It's Murphy's law. Excuse me. I guess folks are still joining in. We have Tyler, Raj, Josh, and Eric. Hey, guys. We have people waiting for Zoom. Charles joined, Raj joined. Hello.
Good afternoon.
Hello. How are you guys doing? How are you doing? Can you hear me?
It's still the beginning of the week. It's yet to be seen.
I know. Beginning of the week. Yeah, it is Tuesday. And it is beginning of the week, no doubt about it. And so, yeah, it just starts like that and goes away and finishes just like that magically. And that is something that happens every week, it seems. Okay, so I think I'm just wrapping some of these open tabs, talk about a couple of new things, and then proceed to our discussion for today. I plan to continue our architectural discussions that we have had up until now, specifically this idea of AWS architecture and Microsoft's architecture center. These guys have prepared a variety of what they call reference architectures or reference implementation for a variety of given architecture situations for business applications. And so we began discussing about just one company, Netflix, and we discussed, specifically discussed, where is that? Here, maybe. And so we went to the architecture center, this location, and studied one of those. That was the content and media sharing scenario. Actually, no, media sharing pipeline, this scenario. That was the one that we discussed a lot in Netflix discussion. And like that, what I would like to maybe pause a minute and ask you if there are any specific questions on this. If that's the case, you should always ask away if you have. But I would not discuss too much about media sharing anymore, but instead look at other applications. And so we'll begin from the top, something like, we'll cover each and everything that they have recommended as a reference, AWS reference architecture in this data sheet that they are recommending to look. And similarly, there is this, which is Microsoft's recommendations as to how people can use a variety of applications and run for a variety of business types. Well, all these types that are listed out here in the drop down, there are quite a bit of them, but we will attempt to cover, all of them based on, if you have interest in something specific, we'll go deeper in that area. If you don't have much interest in a particular topic, we can just go ahead and skip them if you like. There is more content for us to cover than what we can actually cover. So we have that challenge always with us as to what do we want to discuss, what do we want to skip. So with that, I want to begin this idea of opening up this particular aspect of web application hosting and go into deeper in terms of what does that mean. And at the same time, what I would like to do as we discuss these things, I would like to show you some specific details in the Amazon's cloud. So for example, you will see here in the Amazon's cloud console, there are services available. I will walk you through what and how each of these elements, like we will see in these illustrations, apply to actual applications that you will run in the real cloud. This one, for example. So I'll make that connection, make sure that I connect the dots between what that picture says and what actual implementation will look like. And that's our plan as we go along. So I will put this idea on this half of the screen and this other idea on the other half. So I will put this guy on the other half here. And what I will now do is remind you that today Amazon is running into a lot of outage. So as you may have heard, specifically on the East Coast, lots of issues on buckets. There are 20 open issues right now, and most of these relate to storage. If you go and do a quick search on AWS outage, you will find that it was quite impactful. Lots of sites were taken down as a consequence. And the simple way to prevent this is actually quite intuitive. And if you look at the ways to prevent that problem, it boils down to these two things. Actually, just one thing. Don't put all your eggs in one basket. That's what it boils down to. So if you look at the tweet that I have is basically summarizing what is common sense. Don't put all the eggs in one basket. Don't put all your objects in one bucket provider. And that's what somebody seems to have retweeted. But the idea is this is common sense, and people don't use common sense apparently. So as a consequence, you will have a bunch of major companies went down, including Docker, Quora, and there's a whole list of sites that got disrupted. And you can see them, and Slack got impacted. Could not upload files because of Dropbox, of course. Sorry, not Dropbox, but as I as I see that I upload items inside, as you upload a item in the Slack chat, it will not upload. The simple thing, because Slack, the software, uses a bucket, specifically this S3 bucket. And if you have, if you take a look at what we have here, which is, go to the bucket selection. So let's say if you have a bucket here, say I'll go to a sample bucket, something like, your bucket name goes here, for example, that bucket. So we have these items in there. You try to upload something to it, add some files, it would not get uploaded. For example, this picture I want to upload and send, it would not actually go there. That was the problem that people were running into. And because of an outage on US East, Northern Virginia in S3. And what Amazon S3 has indicated is that they have resolved most of the issues. There are still 19 issues open. And so they are working on resolving it. But that basically, bottom line, if you're using one of something, that's a problem. What if that goes away? And so if you look at the idea that you probably know of, this thing called Murphy's Law. You may have heard of it. Murphy. This guy strikes. And Murphy's Law, to be specific, is not to be confused with Murphy's Law, which is a different law, by the way. Murphy's Law is the right law, not Murphy. And so if you look at Murphy's Law, the simple idea behind it, anything that can go wrong will go wrong. And so that's the whole premise of this discussion is, plan for disaster, because things will go bad. And so that is another way to look at cloud. The cloud will go down. Every single thing will go down at some point in time. I can guarantee that part. What I cannot guarantee is, things will work. That's a disaster that will happen. It's just waiting to happen. So you will have some kind of a disaster that will always happen. So you have to plan for it. Plan for a disaster. And this word disaster is a very subjective word. And so, if you plan for it, it basically means you have to add redundancy. Do two of things or three of those things, two or three of the same thing. And if you do it that way, if you're making things redundant, that's going to be expensive. If it is like $1 for one item, you're doing it twice, it's double the cost. Doing it 3 times of the same thing, 3 times the cost. So it is expensive to go redundant. If you want to become redundant, you can. And therefore, this idea of a disaster and is very subjective in nature in terms of what extent can we keep going, duplicating and becoming redundant to the extent of basically avoiding a disaster. You will run into a disaster, no doubt about it. You can avoid it by, just if you have like one implementation of something, you create a backup redundant implementation, and so you can switch over from here. If this goes down, then you switch over to here. And that is a simple way of implementing redundancy. And that becomes expensive by the very definition that you have 2 of the same thing. And so the subjectivity comes into play, boils down to, what impact can you tolerate? Like tolerance of an impact. Tolerance of something going wrong or bad. Something went bad, what is the amount of tolerance can you tolerate? And that thing actually is a business discussion, not a technical thing. The business discussion here, by the way, my sound is a little bit weird today. I'm still coughing and it's not gone. So I'm sorry about that sound problems. If you have my voice not clear, I will speak differently or get another cup of hot water or something, or hot tea. But this idea of business problem. So for example, this afternoon when I was playing around with it, I sent you a message saying that these links are down. And they were down at that time. But, the impact of that was that I could not access it. Now, does it actually impact us? Probably not anymore, because the outage has apparently gone away. It's not out anymore. It is still working. And so we can continue our discussions around those architectural diagrams that we have listed here. By the way, each and every one of them is back online right now. But that doesn't matter. And why it doesn't matter to me? Because I have saved a copy of those things already in my local computer. If you open my folder, you will find those files are already here. So I could, pass these on to you guys in another method. So we are practically not impacted because I had a backup plan. As simple as the backup was just making sure that I carry a copy of these designs with me, so I can give it to you. As simple as that. That's the simplest way of backing up stuff. Like, you know this. It's intuitive. But bottom line is that if you have something which you want to be able to tolerate something going bad, the implication of that is a business question, and that has to be understood carefully in terms of the cost of downtime. The cost of downtime. Now, if you try to measure the cost of a downtime for one of these files here, they were not accessible to me. Did Amazon lose money? Probably not. Did Amazon lose reputation? Yes, big time. Today, people are just complaining about, and if you go look at AWS down and look at all the internet jokes that are happening, things of that nature, you will see that it took quite a bit of hit in terms of its reputation. And there are funny tweets and funny pictures and all that you should be able to explore yourself. But the cost to Amazon is actually reputation. This is, by the way, they call the S3 service is one of the most reliable. And they have a durability number, which you remember, durability. They talk about 13 nines, if you recall. But that was about durability, not about availability. So availability and durability being two different things. I hope you understand the difference. Today, Amazon's bucket was not available. It went down. Doesn't mean that, the durability is bad. It is still, the files exist. All those files, that items that people have put in those buckets. So you have bunch of buckets in S3, and you put those items in there. You call them objects. Those objects are there. They're safe. And the durability did not come into question, but the availability did. And that's the idea that I would like you to remember, that availability is usually lower than durability for obvious reasons. The bucket is still there. It's just that you cannot access it right now. And that causes downtime, but it is not a data loss. Data loss, did data loss happen? No, probably not. I hope not. I mean, if there is a data loss, that's another major issue. But today, it was not about loss of data. It's about loss of access. So when you lose access, your availability goes down. Now, what could have Amazon done differently? I don't know. They will tell us. But what I know is what you and I could have done differently is a very simple way to look at. And that answer is, where did that go? Just don't put all your eggs in one basket. So here we have all the eggs, and voice is down. You mean to say my voice you cannot hear? Is that what you mean to say? Is that what you mean to say? I saw a chat message saying that voice is down.
I can hear you.
Okay. Well, I was curious because Raj says he cannot hear me. Well, is that what you mean?
The voice is back now.
Okay. That's good to know. So the question that Raj has is, won't AWS lose money due to SLA? Yes, if you have an SLA. I don't have one. You might have one. Boeing has one. I don't know if Boeing uses critical data storage on S3. So they might, the default SLA that you get has to be structured in a specific fashion, such as, the SLAs are typically suggested that, SLA, the terms, if you, for looking at an EC2 machine, the EC2 machine will be 0.007 per hour, and that's a T2 micro. And a typical SLA will, I'm saying typical SLA. Typical SLA will indicate that, if you lose the machine access for T2 micro machine for, say, 3 hours down, then the SLA will indicate that Amazon will refund you this money. That's the SLA. Now, is that a big deal? I don't think so. But that's how SLAs are typically worded, is they will refund for the amount of downtime they take. And this is like unexpected downtime, unplanned. And so the SLA language really drives what they have written down. If they might say that, 3 hours downtime, we'll just refund you this multiplied by 3, and that is this number. And so are you happy and excited to get this money back as a refund? I don't think so. Because what happens to you is the amount of downtime that you will run into, you should not worry about this amount of money at all, because that's not the relevant amount for your point of view. For your point of view, if you have a machine that you are using at this price, and that you are using this machine to run something for your customer, and the customers are visiting this site, this service, or whatever you have created, and if they cannot access it, then you are losing money. They could not access, can't access. So the money lost to your business can be way more business loss. Your business loss can be way bigger than this amount. This amount is chump change compared to your business loss, which can be big, depending on what that customer was going to do, did not do, could not access. And that is how you should assess your loss. And that is how you should actually incorporate when you negotiate. So if you're a big company, you get to negotiate your SLA. You can negotiate with Amazon for every service that you plan to use, and you can have them basically agree to specific terms and conditions. It's a legal discussion. It's a legal plus business discussion about specifying what SLA do we want to agree between your big company and the service provider. The service provider in this case would be, say, Amazon, for example. So that service provider has to agree to whatever you negotiate. And if you're a big company, you could negotiate like the way you want, because you have the teeth to negotiate. Small companies, individuals don't have the teeth. So they just take whatever is given to them. Like, for example, this 0.021 of a refund. They will take that and just shut up, because they cannot really influence and modify the standardized SLA given to everybody, right? And that is the SLA. They typically are worded to favor the cloud provider by design. It is something that you will relate to, like, for example, you have Comcast cable service in your home. Comcast service goes down for 2 days, and they charge you $60 per month. And the service was not available for 2 days, so you call Comcast. By the way, why would you do that? But apparently you do. And so what Comcast will say, we are sorry. Oh, they might not use the sorry word, but if they do, they might use the word sorry and say, I will refund you $1. And you feel happy about it, for not for a month, but for that month. For that month, for this downtime that you had for 2 days. So the Comcast company might agree to refund you $1 for 2 days of downtime. And that 2 days basically comes from the $1 comes from 60 divided by 2, is the amount of daily rate that you will receive. Sorry, 60 divided by 30 is the amount of daily rate that you have. So $2 per day, and so 2 days will be $4, yeah, roughly. And so that's the kind of compensation they might offer. And so just a side digression, I think you should Comcast bot negotiate. There is a bot, by the way, these days, and so that you should actually look at. It is called new bot. It's very interesting. This is slight digression, but I think I must bring it up just for the sake of it. The site is called Get TRIM. So go to that site, Get Trim, and in Get Trim, and in that site, Ask Trim, not Get Trim, Ask Trim. So go to this site, Ask Trim, and here you can have a bot negotiate for you with Comcast or with just about a bunch of providers that these guys work with. And that bot is kind of fancy, and I have used it, and it works. It actually got me $10 as a refund for no reason whatsoever. No reason whatsoever. I was just playing with it. So this is something that I would like to ask you to play with. And it's a fancy way of having a bot engage a customer service. And the site is here. And you should install a Chrome plugin. Watch the Chrome plugin engage into a negotiation chat with the company, and you will have fun. You might receive some money as a consequence of doing that, but it's just awesome. But let's skip that discussion. You can do that later. What I want to do now is continue with what we were discussing, which is here, these guys. So we will begin discussing this idea called, the first idea described here is web application hosting, and that's the blueprint defined here. I will download that blueprint, which is already have downloaded. I will paste a link for you, which you have already, I think. So you have a link to that file, which is here. That's what I'm discussing right now. And so the link is coming in chat here, and I'm going to open that up in my Finder, and the Finder is here. And so let us understand what this does. And simply speaking, what does this do? So if you have any kind of generic web application that you want to install and have it run in the Amazon's cloud, this is the Amazon recommendation for a reference architecture for a general purpose multi-tier web application. How would you host it on a large scalable infrastructure like Amazon's cloud? What you will see in this picture are a couple of top level observations. One of them is this letter A and this letter B. That these two things are basically indicative of a fact that your design is highly available. So that's where the word begins with, highly available at the very top. Now let's understand what this high availability comes from. This word highly available is an indicator of using two different zones, A and B. And that zone is also known as availability zone. And you may have seen in Amazon's examples where you go to Amazon's website. So let's say console Amazon website, and you will find that you try to create a machine somewhere in some cloud. that they will give you a choice to select a particular availability zone. For example, here, do you want to choose a network? Do you choose the VPC? Do you want to choose a subnet? So I have a subnet called that subnet. It is default in US West 1C. So that's the only subnet I have. Now I cannot make it highly available, unless I create another subnet. So I create a new subnet and create this one is already, by the way, in the US 1C, US West 1C. So I want to create another subnet and I will call this in the same VPC, and availability zone I will select to be 1B. And I will choose something like this number, /24, and create it. Okay, overlap. So we have to go overlaps with pre-existing CIDR block 20. So we have to go narrow. Hold on. I think this block is too wide for our consumption. So we have to create a different VPC. I think that's the best way to discuss. So I'm going to create a new VPC so I can establish this clarity of idea among ourselves. So creating a new VPC, just giving it a name, Cloud Genius, and CIDR block that you know already. This is the CIDR block I want to use. And the tenancy I will use as default and create. Now in that CIDR block for my newly created Amazon virtual private cloud, I will then go and create subnets. One of the subnets is already made available, but this subnet belongs to the default VPC. I will go to this VPC and create two subnets. So this is the subnet for A, and it maps to this A region, and my selection for CIDR is going to be 10.0.0.0/24. And this is going to be created in the 1A availability zone. Their name is going to be A, and I'm creating it in 1A. Oops, copy, create. And then what I just did is marked out and demarcated availability zone A, specifically US West 1A. That AZ, that availability zone, I intend to use in one half of my application, and in the other half, I would like to use this zone B. So create another subnet, call it B, and then select it to be in the Cloud Genius VPC, and select the B availability zone, West 1B, and give it a CIDR block. And create. Okay. What am I doing? Okay, I see what's going on. Okay. So create a subnet, again, B. In the Cloud Genius VPC, select the B preference, and then 10.0.0.10. This should do it, I hope. I think so. So B in the 1B subnet in the availability zone 1B, and create. Okay. Our demos are going to be bad today, apparently. What does it say? Value parameter availability zone is invalid. Subnets can currently only be created in the following availability zones. Okay, this is probably a service error. The service error reads something like this. It is preventing me from creating a subnet in the 1B availability zone. It says value for parameter availability zone is invalid, meaning you don't want to select 1B. That's what it's telling me. Subnet can only be currently only be created in the following availability zones, 1A and 1C. Something is preventing the error code. So if I choose 1C, it apparently will let me create. That is what it's telling me. Go do it in 1A, 1C, not in 1B. We are busy there. Apparently something must be going on. So create. So it's creating, and it did. So what I just changed my design in from what I had in mind was this B into C. So now I have a picture that looks like this. So I have basically a redundant infrastructure that I'm planning, creating a separate VPC in two availability zones, the A zone and the C zone. That's the fundamental premise of idea that we are discussing in this picture. It is A idea here and the C idea that I just created, which is shown as B here, for example. Now, in that distribution of this, if you draw a line across this, like how my mouse moves, you will notice that we are basically beginning to create redundancy across the board in every single design element. Now, if you look at just one of those regions at a given time, let's say look at only A or maybe only C. So we'll look at one at a time. What we are really looking at is this customer that we have. This customer will have to visit some service that we will offer. And the first thing the customer will typically do is go to Route 53, which is your DNS query. And in that DNS query, Route 53 is like Cloudflare or like Google DNS or any of those DNS services that you might have. And that will define where should that traffic go forward. And since we are going to create our infrastructure in this segment here for the A availability zone, we will be using this DNS entry that points to this infrastructure. And that entry we need to be creating in our DNS servers. And so that is exactly what this customer will find out from the DNS entry. And when that customer is able to, then he or she will then show up at our door. So basically her browser will show up here at the first item to greet. First thing it greets is your load balancer. The typical scenario is you have a greeter, a traffic cop. You will be greeted by a traffic cop, and the traffic cop will then decide, okay, where do you want to go next? And so that traffic from this customer will get forwarded to appropriate web servers. And then these web servers might have a response for the customer. So the web server might respond back saying, okay, here is the response, so that the customer receives what they want. In a subsequent transaction, the customer might want to ask for something else that this web server may not have. And so in that case, it might go to the backend and look at some application to be processed. And that process might finish. And when the process finishes, that it will respond back to the web server, and then the web server will in turn respond back to the customer saying, yeah, we got your process finished, and so here is your result, and the customer is happy again. And in the consequence of doing these things, what we are really looking at is building out this application, which might run a process for you, might need to access some data, and that data may be stored in a database or database server, to be specific. But all of these things that we just drew in this picture, which are also here, by the way, you have these web servers, you have these application servers, and then on the other end, you show that there is a database server here. And so what these things will do in this illustration is show you the idea of scaling at the same time, high availability, both together. So in our implementation, as we go along building, what we are looking to accomplish is, if you look at this entire flow in a simple fashion, it is basically a customer trying to hit your load balancer. That load balancer hits a web server, and this web server hits an application server, and the application server might hit a database, and then database usually has the final answer or final result, or that needs to be computed or pre-computed, and that's how the transaction can eventually go back to the customer. However, if you have a very, very simple design, you don't need a load balancer either. If you just have like one simple customer visiting a web server, an application, and database, and that's a 3-tier architecture right there. However, in most our cases, we know that this customer is not the only one that visits. So we have like multiple people that visit our services. So they will all be visiting. And so we need to be able to have a thing called a load balancer that will then distribute among a fleet of our web servers, not just one, but a fleet of web servers like that, that will scale out and in as needed. And same thing here. You have this application scenario where application servers are running for you. If you have multiplicity of them, they will be able to scale out better and be able to serve your customer needs appropriately. And that scenario is feasible. You know how the idea of scaling works. So the idea of scaling, as it translates to Amazon's scenario here, will be that you will have to create what is known as an auto scaling group. An auto scaling group is basically a collection of machines that grows and shrinks according to a set of principles or measurements. So if you look at just simply launching an instance, you will get one machine that you will launch, or you might get like a bunch of machines that you will launch. So you can launch and say, I want 100 machines. You could do that like this. However, there is this button, click here to launch into an auto scaling group. And what this does is creates a launch configuration. So here in that launch configuration, what you tend to define is the machine image that you intend to use and the type of the instance, which is going to be either a T2 micro or N3 medium or some other size, basically in that machine image. So you create a launch configuration is what you will typically end up doing for any auto scaling group. So this is your auto scaling group. And in that auto scaling group, for it to be able to scale automatically, you need to define what is the machine image that you need to use, and also the size. How big the one you want, T2 micros, or maybe M3 mediums, or some other type that you choose. And similarly, the machine image, is it going to be based on Ubuntu web server or Ubuntu, or you want to run Windows here? Whatever you want to run, you will need to provide that image and specify a size. And these two things together constitute a launch configuration. And that launch configuration basically translates to, when you create a launch configuration like this, you will land into a page which tells you to give it a name. So you can give it a launch configuration, my web servers, I should say, and I can enable monitoring on this, and then proceed to add some storage and configure my security groups. And you can choose an existing security group if you like. And so say one of these guys, and yeah, I think this one is a good one. And then I'll review and create a launch configuration. Just by creating a launch configuration, what you're doing essentially is to define that I want this flavor of the machine image, AMI. I would like it to be Ubuntu boxes, and I would like it to run T2 micro. So when you go and automatically scale on demand, you will basically follow these principles of scaling, that you will use Ubuntu machine image and a T2 micro size. Now, for practicality, people typically not begin with here, but what they will typically do is build their excuse me, build their machine image on their own laboratory of some location, on a test situation or a test infrastructure, base it on something like Ubuntu or Windows or some other operating system to begin with, add whatever else they want to add, and then decide that that is the machine image that I want to go forward use. And so they will be able to capture an image. Capturing an image is basically taking a snapshot of the machine that you have created, and then use this machine that you capture. It will give you a new AMI ID. And that ID is what you will use in your auto scaling group. And then you specify that size, whether you want T2 micro, M3 medium, or some bigger machines. There are lots of sizes available. You can select the size, you select the machine image that you like, and you put that in a scaling group. And that's how you will begin automatic scaling, by specifying a launch configuration. You will do the exact same name or the exact same game here. It will be a separate auto scaling group. This auto scaling group will not just run your web server, but also will have, this group will have some Linux machine and your application installed. Together will constitute a new machine image. And that is going to be a different machine image ID that you will receive as soon as you capture a snapshot of that image. And then you define the size you would like to have, like T2 micro or some other size, and then defines another ASG. So this structure that we are looking at is going to be available for us in a scenario where you will have a load balancer. This is a public facing load balancer. The people outside will come and visit this load balancer. This load balancer will then deal with an auto scaling group of web servers. And this is going to be a collection of web servers. And these web servers will then deal with another load balancer. And that load balancer is going to be an internal load balancer, internal to your cloud. And the people who visit this load balancer are actually these web servers, not actual people outside. They cannot visit this load balancer. No, it is not meant for them. It is meant to be an internal only load balancer. And the purpose of this load balancer is to be able to balance the load among all these different web servers asking for resources from another application auto scaling group, which is the group corresponding to your app servers. And these application servers will also be able to auto scale because you put them in an auto scaling group, and then they will connect to a database. Now, why do we see that, the scenario of database scaling? Why do we don't see any references to that in the picture? Why don't we have a similar auto scaling group defined in this illustration? We have an auto scaling group, this yellow item here, and this auto scaling group yellow item here. But why is there no auto scaling group indicated in the RDS setup? That could be a good question. So I will attempt to answer that. One of them is that in this picture illustration, what they are showing you is that they're using RDS. RDS. What does that RDS do? It's actually a service. It's not a box that runs your database server, but it's a service. It is by itself scaling already. And so if you look at this example of a service that you will find is available here called RDS, it tells you that you could choose to create a new database service. And I know in Boeing you are creating a database service option, and you could potentially do something like this. For example, like many cloud providers will provide you this service. And creating this can be a challenge. You have to support a variety of different database servers depending on your internal requirements, and then come up with a situation where, say, for example, MariaDB is available. So you could select that as a choice and then decide whether you want it for development and testing or for production. And that's a very critical discussion that you need to have, because that translates to whether or not you will basically decide to have the database service running across A and C here and here together or not. If you are doing high availability scenarios, you're doing in this availability zone as well as this availability zone. And so your service needs to be spanning multiple availability zones already. And that is a high availability design. That is what is Amazon suggesting here, is to deploy a database in multiple availability zones. You could go that route. If you have internal private cloud, you could create 2 different buildings in 2 different locations, have private cloud OpenStack deployed in this building and OpenStack deployed in the other building in another location, all inside the company, and have your database services, specifically something like this, MariaDB, run across 2 different buildings. And you have to configure it very diligently. You have to understand, you really need to know MariaDB at that time to be able to run a scalable service. It's a specifically focused discussion on that particular database. But having that capability, what it will translate to is, in your company, you could have a setup, something like building A and building C. So 2 distinctly different buildings, both running a scalable, synchronously replicated database service, providing internally a high level of availability across 2 buildings. This is building A, this is building C. So think like that if you're deploying something in a highly scalable situation for your company's usage in the company, all inside. In case of Amazon, they have a synchronous replication already established among database servers that they will plan for you and run an RDS here as well as here, provided you choose the production mode deployment. So if you go back here and choose production, that is what you will receive, multi-availability zone deployment. Whereas if you select this, it is going to be either one of those, not both. So it is going to be not high available, just so you understand this. So this dev test is not highly available, but it's okay, for testing it's just fine. But for this scenario, you could, in the next step, select that I want to run this MariaDB version, let's say the latest, and I want to select a small machine or maybe a medium size machine, let's say M3 large, M3 medium, yeah, that machine. And it says I want to select multiple availability zone deployments, so I'll say yes. And then I want to have some storage, so I'll say 100 GB of storage. I provide that, and then I create an instance identifier. So basically it's a name, so some name here. So just choose some name, then choose a master password, username and password. So here is going to be simple as master. You can choose whatever names you like, totally, and choose a master password and confirm that master password, and then proceed to the next step. When you do that, you're basically creating a new highly available database as a service across 2 different availability zones in your chosen VPC. So for example, my chosen VPC is this one. And so I can create a new subnet to hold my database. And that's a recommended practice. Currently, if you remember in my design, I have just one subnet here and one subnet here as I build my new VPC called Cloud Genius. Now, what you will notice is that these guys they're going to be creating new subnets just for the database itself to be created here as well as here. So you will have 2 subnets, one for this in your 2 different regions. In our example, it will be A and C. That's what you will see when I proceed forward with creation of a RDS deployment. I will be basically creating a separate subnet just for the purpose of databases, which will be used for synchronous replication of databases. So say, for example, this MariaDB is going to be replicated and synchronized as a high availability solution. As I proceed forward, I will say, create new subnets for databases. I'll say yes. Do I want my databases to be publicly accessible? No, not really. In the availability zone preference, I will, basically have no preference about which availability zones that they seem to actually, they should allow me to select my availability zones of my choice. But apparently they're not giving me a drop down for some reason. It could be a temporary issue, or I don't know what that issue may be. But I expect to see a drop down here, which allows me to select the availability zone A and the availability zone C for Northern California. Similarly, in database name, I will have to specify the name of the database inside the database server. So it could be something like my WordPress DB, for example. And then I can choose to enable encryption or not if I want to. I can also make automatic backups and retain backups and decide which time window do I want the backup to happen. And there are lots of options available here. So I can decide that my backup should happen in a span of 30 minutes every night, middle of the night. And then I enable monitoring. And then do I want to automatically upgrade the version of MariaDB? Yes or no? And do I have to select that window? When do I want to upgrade? I could say do upgrades on Monday at the midnight. And then I launch. And that sequence of operations will effectively launch a highly available database as a service across two availability zones, which is one of them is this one, and the other one is this one. So what you translated this into is a setup in which we have like a collection of web autoscaling group, a collection of application servers, and a database service, which, by the way, scales by itself. And not only that, it spans across two different availability zones. So availability zone C and availability zone called A. So two availability zones it will span across. So this database service will be across two AZs, as you can see in the picture, which goes, where did the picture go? Okay, here. So you can see that this item number 7 and here 7 both are running a same common synchronously replicated database service in the A as well as B region. And you have application servers. These are also running across two different A and C or B availability zones, basically two buildings. So think of availability zones as two distinctly different buildings in the example of Amazon. And Amazon will describe how they have defined different availability zones for you. And by the way, they don't actually tell you which availability zone A, B, and C that I seem to have in my US West 1 California region. I know I have A, B, and C, and apparently I cannot create a subnet here, which effectively means I have only A and C right now. Now, what does that translate to? Is this is one building, this is another building, this is another building. There is probably something going on here that doesn't let me create a subnet. But these two buildings are available for me in the California region. Now, in reality, what Amazon does is they might have more than 3 availability zones in California, but they might arbitrarily allocate these 2 or sometimes 3 to a given customer like me. And so my A and B and C could be totally different than your A and B and C. It really depends on what Amazon randomly decides to choose. In reality, they could be having more than 3 availability zones for the California region. They call it region, but it's effectively a separate cloud. And so that's what you're looking at here when you select which cloud you want. They call these things regions, but effectively they're independent clouds because you cannot even share your private key pair across different clouds. So they're practically independent. So think like that. In the case of Amazon, these are separate clouds. They don't call it like that though. And so I want to clarify that piece with you. Now, having discussed, is this somebody chatting with me? but not this guy. Not talking about him right now. Later. So let me close that reminder. Okay, and so back in what we were discussing in this picture that we have opened is the scenario essentially is that if you want to host an application, you want to be able to create a setup pretty similar to what this illustration essentially is. I think I was able to illustrate to you how this database services will get created across two different availability zones. The idea of creating an auto scaling group involves a couple of things. For example, I mentioned about launch configuration. Sorry, not launch configuration. A launch configuration includes the image that you want to use and the size or the type of the machine you want to use, say T2 micro or M3 medium, like that. And this is just one aspect of an auto scaling group. The other aspect, this is just one aspect. The other aspect of an auto scaling group essentially translates to measurement. Measurements meaning monitoring. You have to monitor how heavy or how light the work is on your boxes that are a part of your auto scaling group. So that monitoring measurements will basically dictate how many of these boxes should be up and running at a given time, and whether they should add more or cut some. That decision has to be automated, and it can be automated perfectly if you actually monitor what's going on in these boxes. And the way to do that from a very simple logic perspective would be something like this. You at least have in this picture, where is that picture? In this illustration, there are at least two auto scaling groups. Like one of them is this one, other one is this one. These two auto scaling groups could independently scale out of and scale in, independent of each other. So this can scale by itself, irrespective of this. So if you want to decide whether you want to scale and need more web servers or need less web servers, you need to be able to measure something. And I want to ask you, what would you measure? So say, for example, we are discussing about web servers, and you have these web servers inside an auto scaling group configuration, and you have these machines laid out like that. And you know that anytime a new machine comes up, it will get configured according to the launch configuration. This launch configuration decides the machine image that you want to use and the size of the machine that you want to add. So new machine comes up, it will select whatever the launch configuration says, and that gets allocated. That's easy. The question that remains is, when do you add a box? And when do you subtract a box? And that's what this idea of auto scaling group comes into play. So the question is up to you. How do you make that call? When do you want to add a machine? When do you want to reduce a machine? And that's how would you go about setting rules, or what I would call policy. What is your policy to grow? What is your policy to shrink? And what metrics do you use? So that's a question to you, because it's really up to us as to what metrics do we want to take a look at to make a decision as to when do you want to add one more box or reduce one more box. So this is the shrink policy, and this is the grow policy. And you need to have metrics or measurements about something. So what is that something, and how would you set those rules? That's the question I have for you. So any takers? So this will be the example in our discussion is a web server auto scaling group. And the question essentially is, define grow policy, which is this one. When do I grow? And define a shrink policy. When do I shrink? So that's the question I have for you. What do you think? How would you go and decide these things?
Nilesh, would that depend on the application per se? Like
Yeah,
if the web
exactly.
server without much
Yes. So
data or traffic?
yes. So if it's a web server, just a simple web server that serves static content, the simple thing. Static content as in, whatever, pictures, HTML, CSS, JavaScript, simple things. So simple, let's begin with some simple examples. So simple web server auto scaling group. If that's the case, and you have, let me go here in this picture. So we have this illustration, and this is our web auto scaling group. So the web auto scaling group, and this is the application auto scaling group. And so the question I have essentially is, when do I grow? And when do I shrink? Grow, shrink. So grow and shrink. That's the question. How would you decide? What would you measure? And when do you want to grow? When do you want to add? And when do you want to subtract? That policy somebody has to set. And it is you, dear, right now. And so you have to come up with something that makes sense to your case. And so this application that you have, or the web server you have, these are auto scaling groups. They will scale. And the fact that they are auto, the name auto indicates they have to be driven by a rule. So you have to write down those rules and specify somewhere here in Amazon or some other cloud. But let's do that. But before that, I want to actually ask you and to read your mind as to what are you thinking? Because, by the way, Amazon will help you in accomplishing this idea very, very easily. But I would like to hear your thoughts. They will do these things. They help you accomplish and set the grow policy and set the shrink policy for you. They will do it, and we will get there. Set shrink policy. They will totally do it for us. But before we jump to the finding out about what they will do, I want to ask you a question. So you use your imagination to come up with something that might make sense to a web server scaling out grow policy. What would that be? When would you grow? What would you measure? Not how, but what would you measure? How will you measure is a different case, and we'll talk about that as well. But what would you measure? What do you want to measure? Anybody? Any takers? Nobody?
First thing I'll measure is response time.
Response time is a good one. I mean, these people who are using the desktop and the phones that they have, they will hit your web servers, and how quick the response back to them is one good metric. So yes, one metric will be response time.
And the second is usage of the machine, like memory or
Yes,
CPU.
good one. Memory consumption. More.
Hard drive peak.
Yeah, disk space.
Disk space or disk response.
IOPS. Right?
Yeah.
Yeah. What else?
Just the hit rate itself.
Sorry?
Just the hit rate itself.
Hit rate. How much are the boxes getting hit? Is that the hit rate you mean?
Yes.
Okay. More. A very simple one that it's very obvious, but you will see it somewhere. Let's go run it, and I'll show you what I'm talking about. Simple metrics, edge top. This will tell you. I don't have it edge top here. And so you will see this HTOP is a tool available that basically gives you a bunch of metrics already. And so I'll just run it right now, HTOP. And here it comes. So now read. This will give you a clue about what am I talking about. So there are lots of metrics here that are relevant. What are those? And how would you identify the right ones? The HTOP is a monitoring tool that monitors CPU and system performance. So this you can run on Linux and Mac and a bunch of other places, not Windows. But the idea is you look at here, see what's going on here, the 45%, 28%, 21%. What is that number? Is the CPU consumption. So the 1, 2, 3, and 4, and 5, 6, 7, and 8. These are 8 CPUs I have on this machine. I have memory consumption of about 20 GB consumed out of 32 GB total available. And then I have some swap that I'm not using because it's not needed. There is enough memory already. I have 384 tasks, these many 2 running processes. Average load on the machine is about 2. The uptime is 3 days, and the current time is I think this is not the current time. I don't remember what the metric is. But if you see the top level 8 items, 1, 2, 3, 4, 5, 6, 7, 8, they are indicative of CPU consumption, which is a good one to look at. If you try to attempt to run something very exotic, or if your applications that you have, like in my machine, you will see in the very first line is running this application called Zoom. This Zoom application excuse me, it's consuming about 25% of CPU, 31% of CPU, 46% CPU, like that. And so you see those numbers vary as we proceed along. You will also see seasonal and holiday buying, correct? That's a manual method of adjusting. By the way, Shiv says seasonal and holiday buying. That's a good one to look at, by the way. And so back here, I want to add here is this item called CPU consumption. And then Shiv just added another metric, which is holiday patterns, holiday purchase patterns. So if you have something specific, patterns, generally speaking, if you know a specific pattern available, you want to accommodate for that already. Now comes the time horizon on which these things need to change. So we have a bunch of metrics, for example, how much memory being consumed, how much disk IO performance per second is being hit on the hard disk that is locally stored here. And we can measure these things. And then we can come up with some kind of a policy, a grow policy. So if you're seeing that the CPU consumption is close to, say, 80%, then you should trigger this. And you should trigger this in a more systematic fashion, and I'll describe what I mean by that. What I mean by that is, let's go here to my whiteboard, and what I want to be able to say is, I want to not randomly, arbitrarily just add a box and add a box and add a box at the flip of a button. When I see 80% CPU, I just add one more box. And I don't do that immediately. What I want to be able to do is watch for a period of time, say 5 minutes. Over a period of 5 minutes, if I see that my CPU is actually consistently 80%, then I will add a box, and then watch again. And I expect that this CPU consumption will actually drop and maybe it becomes 50%. And then I keep watching. And if it is 50, I have no problem. And I keep watching, and it keeps going, and like that. So that's the grow policy. You notice that I don't immediately jump to a conclusion as soon as I hit 80%. I don't immediately say, okay, add one more. I don't do that immediately, but I wait and watch for a sustained period of time and then come to a conclusion that there is time for me to actually add another box to the game. And when I do that, I expect to spread the load across more than this one additional box. So it will spread the load, and I expect that the overall CPU consumption will go down. So I'll start watching again for a period of time. And if I see that that number is, reasonable boundaries, I'll be happy with it. I'll just leave it alone, not touch it. And that's the way to decide whether I will execute my grow policy. If I don't have this wait period, what is the problem? Do you know what happens when you don't have a wait introduced, a wait and watch game? If you don't do that, just immediately click one more. What happens? You run into the situation called flip-flop. Immediately start a box for no reason. It may be a minor spike of some sort, for a transient spike of CPU percent going to 100. And you will occasionally see that, like for example here, occasionally you see that, these percentages go high, but they're not sustained high at the rate of like say 23 and 17, 16 and 30 and all that. Those numbers are reasonable. They're not shooting up all the way high to say 100% all across the board consistently. That is not happening. And so the machine is chugging along fine. In fact, I noticed that the machine's fan is not running right now. It is so comfortable that the fan of the CPU of this box has not started. It is not making any noise. It is just quiet. Now, when does the fan policy hit? It's basically the same kind of concept. You want to not flip-flop. You want to wait and watch and cool down this computer and start the fan only when you see that the CPU consumption is crossing a threshold. And that if you don't wait and watch, you might accidentally turn on the fan, turn off the fan too much and for no reason. Similarly, you will also occasionally flip-flop grow a machine for no reason and add one more accidentally and then wait and watch again. Actually, you're not waiting and watching. You're just responding to random behavior. So if you see that the CPU consumption goes up, you immediately add a machine. That's okay, but it's just unnecessarily adding a machine for a transient spike. That may not be necessary. It may be not appropriate. So that's the reason why you introduce a wait and watch scenario. So that we just briefly discussed how you would implement a grow policy. Very, very similar to this policy would be the shrink policy. Shrink. Now, when would you shrink? For example, the same way of thinking, if you notice that your CPU consumption is of the order of 50% on the box, or rather all these boxes that you have in your auto scaling group, and you have, let's say, 3 boxes in the ASG. Each one of them is chugging along at 50. Fine. You do nothing. Let it run. However, when you notice that these boxes, like quite a bit of them, almost all of them, and the CPU consumption has gone down even further to say 9%, and it stays like that, wait and watch for a period of 5 minutes, and it consistently stays low at that level. What does it indicate? This watching game tells you that the 3 boxes we have are over provisioned. And so at that time, your shrink policy should kick in and say that, you know what, I think I'm wasting my resource. I think I can do without 1 box. So let me now conclude that for the last 5 minutes or so, I'm noticing that all these 3 boxes are spending only 9% of the resource, maybe a CPU, so whatever metric that you decide, or maybe a collection of metrics. I'm just picking up some metric and coming up with a example shrink policy. And so if I decide that my computers, my boxes that I have in the auto scaling group are over provisioned and underutilized. This might happen, underutilized. It might happen if the customers go away, or if it is nighttime and nobody's actually hitting your services, or if it is down season and not many customers are actually accessing your service. You will notice that, with a sudden drop in traffic, you don't want to over provision, you want to not remain underutilized, so you want to exercise the shrink policy. And when you shrink, what will happen? What do you think will happen? Is you basically go and shoot one of those boxes that you have. You say, you know what, you go away. So now instead of 2 boxes, your auto scaling will have, instead of 3 boxes, your auto scaling group will have only 2 boxes. You just shot one of them. And it will automatically kill based on the policy you put in place. And so this auto scaling group is a auto killing, auto generating box policy. Think about it like that. So now we'll go here and look at the question. We should give you a 10-minute. Thank you. Yes. And so let me read the last question. Shiv says, question is, in the case of a web server, why can't the hit rate alone be enough? Number of concurrent threads used to a metric to grow and shrink. The question that you read, that I read here, it's a why can't question. I mean, nothing is preventing you from setting your rules and your policy. The best policy is the one that works for your application. That's how you should actually tweak these policies for a given application on an application by application basis, and adjust whether that particular policy that you want to implement will actually work out. And you need to monitor left and right every single thing that you will have in your cloud, every box, every service, every load balancer, database services, every single thing that you deploy. You need to have a very systematic method of monitoring that. And it's only through use of this monitoring of metrics that you collect from your infrastructure that you can then conclude what is going on. And once you know what is going on, you can then apply the idea of using those measurements to convert them into what I suggest, or the words that I use is the grow policy, the shrink policy. And that's how you translate these things into. So where is that picture? This picture, this auto scaling group. This auto scaling group will actually, both of them will operate on independent grow and shrink policies based on collection of metrics that you will accumulate on these application servers. That's what you will measure. How are these boxes doing? And then based on that collection of metrics that you will accumulate, that you will put those concepts that you have in terms of measurement that you generate from these application servers, that you will then use those into constructing a shrink policy and a grow policy in your auto scaling group for this application servers. Same thing, except what just happened? Reopen. So same thing, but applies to web servers. These guys. And so you need to measure your performance of web servers and then decide to grow or shrink on a systematic policy in this auto scaling group. Now, some people will ask me this question, and I think it's a good question that you did not yet ask. Is we talk about high availability, but then all along the way, why are these load balancers not apparently highly available? Why are they not in A and B? So the picture shows only one in the middle. Only one in the middle. What about the high availability of these these load balancers? So let me tell you that they are already in multiple availability zones by design. And I'll go to a load balancer and demonstrate that to you when we are in the Amazon cloud. So where is Amazon cloud? Amazon cloud, did I have a tab open already? No. Okay, so here we go, Amazon's cloud, and we'll see those things like I mentioned, the load balancer service. It's a part of your EC2 setup. So you have to go and look at deciding to start a load balancer. It's right there. And when you create a load balancer and you say create, it lets you create two types. So an application load balancer and a classic load balancer. And I think the idea of a classic load balancer is what we should discuss first. This is the traditional load balancer that you would expect. And so the idea here is that you would give it a name and select the VPC you like. And then you have to select two different subnets. So subnet selection in my Cloud Genius VPC, I need to provide two subnets. So I have a subnet called 1A and another in 1C. So I'll select both of them, 1 and 2. So I've selected both subnets. I will also select to add a protocol for HTTPS and then choose whether or not this is an internal load balancer or you don't want it to be an internal load balancer. That choice has to be made. That choice is what you will make here in this selection. What is this? That selection that you have translates to this idea shown in this picture. For example, this elastic load balancer is internal inside your VPC, whereas this one is public facing. This box is public facing. This customer can actually hit the elastic load balancer directly, the number 4, not this internal one. And that selection is what you have in this checkbox that you saw here. So that's what you typically do is define in a load balancer. You decide that my load balancer, whether it's going to be internal or public. And these load balancers are already spanning across two availability zones like US, West, 1A and 1C. They're already spanning across two AZs. And when you create them, you also have to decide what to listen for. These guys, we need to listen for HTTP traffic, for example, on port number 80 inside, and HTTPS traffic on port number 443 inside. You have to go and define those listeners. That's what this thing that we did here shows you. The protocol that you want to use for the listener configuration specifies the services that you want to respond to and the port internally, what you will actually translate to. So a load balancer basically does the action of translating. The idea here is, for example, I'll draw this again. I think this is a little bit confusing. So I'll draw it again, this piece. What I want to be able to say is that you have this load balancer here that will respond to port number 80 from outside, respond to port number 443 from outside, but internally, when it divides the traffic among a bunch of different machines, internal, you will internally talk only HTTP. You don't have to talk HTTPS, not needed, because it's all internal to you in the cloud, in your VPC. You don't have to go this. Oh my God. You don't need to go this way at all. That's what this illustration shows you in this picture. It says that when you create a load balancer and that you have the listener configuration specified, that from an outside perspective, you are balancing HTTP and HTTPS. So both these ports on the load balancer side, but on the instance side, on the machines internally, you don't need to use 443. There is no need to. You could, like this, you could, but no need to. There is a difference in the way that this operates. If you are using HTTP secure internally, it is not necessary, but you can. And if you decide to, then you have to worry about certificates and you have to provide those certificates internal to the instances. Whereas if you are going like this, then the certificate for SSL terminates right here. So the idea here is your SSL endpoint is this. It terminates any SSL traffic coming on this port from the outside, terminates here. Internal traffic can go along unencrypted because it's all inside your VPC. It makes your design simple. That's the way to distinguish and remember that this SSL termination, you make sure that you can use this by making your load balancer deal with SSL, and don't have to worry about SSL certificates on machines inside in your application, auto scaling group. You don't have to worry about these things at all if you choose 80/80 all across in your instances. And that's what this selection applies basically. And so you could select that, and I think that I recommend selecting it this way. There's no reason to worry about SSL inside your VPC. An example of that would be if you go to secure.boeing.com internally in your company. This site is internal to you, and you will see that it just opens up for you if you are in the company. From outside, it is not accessible. And this site internal to you is HTTP. If you try accessing the same thing with HTTPS, it might give you an error because it's an internal site and it is does not need to be HTTPS enabled. Doesn't mean it is less secure. It's just that's how you have implemented it. So I know this because I've tried it. One of the colleagues from Boeing was actually showing me this. Why is it not secure? Was the question that he had is why does this site called not secure.boeing.com, but search.boeing.com. What am I talking about? Hold on. Search.boeing.com. This site, which is your internal search engine, is not secure apparently. So that was the question that somebody asked me the other time, previous sessions, one of those sessions. And the question was, why is it not necessary for search.boeing.com to be secure HTTPS? And he was having a debate, and I think that was a good debate to have. But the fact that I cannot access it, search.boeing.com, makes it secure to begin with. Because I'm not inside the company, I'm outside. If you are in the company, you can. And that way, it is already secure by the fact that you walked into the building and you landed on the Boeing network. So that's the conceptual idea here, is that internal sites don't need to be HTTPS, doesn't make them less secure. It's just convenient. If you want to take that route, you could. Now, having discussed this, let me conclude this discussion, and I will take a short break like you're advising. I will take that, but I will just make sure that I cover all the aspects regarding this auto scaling group discussion and group policy, and I'd like to demonstrate that also at some point. So let me get to the picture here. So a couple of other things here that are apparently not multi-availability, multi-AZ. So we have A and B. What about this guy, S3? Is it independent of availability zones? Apparently, that's the thinking that Amazon seems to have, is that they have advised everybody that you don't have to worry about replicating Amazon S3 buckets across multiple availability zones because they will take care of it. That's what they told us. And today, we saw what happens. We saw this. And why did this go down? It went down, and you have news about it and all over the map. It is not that they are not doing it in multiple availability zones, but what you will notice is that the problem seems to lie only in US East area, one area, which is basically the Virginia area. That's where the problem actually is. In that Virginia area, they have A, B, C, D, and E availability zones. They claim that their buckets are actually spread out and are balanced across multiple availability zones. But something has happened today that causes the entire bucket infrastructure to die. And if that happens, this is like Murphy striking. Something goes wrong, will go wrong at the very wrong time. And it happened today. And so what can you do to prevent this? The simple way to deal with this would be to have a backup plan. A backup plan that we will have in another discussion. So there are lots of charts, these pictures like these. There is one for disaster recovery. Also, we'll cover that discussion at that time. Let's see if there are any other elements that are independently isolated and are not apparently redundant. So S3, they claim that they are redundant, but the entire cloud, I should say entire Virginia region for buckets went down as a consequence. This bucket in Virginia region were not accessible, and that's the cause of downtime. So the A and B and C, D, E, all these guys here in Virginia were all of them down. So you will see that they will give you this choice of creating a where is that? I think I want to show you the 5 availability zones that they have in Virginia. So if you go launch an instance, you should be able to see them. And go configure, and you should see that I have these A, E, C, and D. Again, B is not available to me apparently. So I can select A, C, D, or E availability zones, 4 zones, not 5. And that is how they have given it to me for my account. Your account may be different. And so that aspect of S3 down, as you understood today, the idea of this also seemingly is not across multiple availability zones. Is it highly available, highly resilient? The answer, again, claimed by Amazon is it is highly resilient service. Route 53 is spanning across multiple locations, geographically distributed worldwide. And that's the claim that they have, which is what you saw. And same with CloudFront. CloudFront is by design in multiple locations. And just today, they started another endpoint for CloudFront, which is Philadelphia. So Philadelphia, CloudFront. And there is news about it. New edge location in Philadelphia. Posted 24th of February. So just recently started new edge location, which is nice to have. And so with that, I want to take a short break. I'll drink some hot tea and come back. I will also start a timer. And I'll actually walk away and get some hot tea. Thank you, guys. Thank you for bearing with my cold voice. I mean, my coughing voice mostly.
I think we should continue. Let's see if we can make sure that everybody's there. Yeah. Can you hear me? Are you back? I am not able to see you for some reason. Let me see what's going on. Okay. Okay. So I will continue. I'll resume our discussion and I will start projecting my screen and we'll take up the next discussion topic, which is in the architecture section. We will switch over to this content and media serving. I think we already discussed that piece. So the idea that we have here, I would like to discuss especially for today, is this idea of fault tolerance and high availability discussion, which is probably relevant for us to discuss right now, given the outage that is happening in Amazon's cloud. And so I'm going to paste that link for you here. That's the PDF file that I will open. And it is about high availability. So you will see that it is one of those files. Which one? This one. Yeah. So that's when I open. And now let us understand this situation here from a user's perspective as to what the illustration that they are trying to provide from a user's perspective. The idea of being able to have a fault tolerant design. Design that will accept something going wrong and still continue to work. So a couple of things before we talk about these things. One of them is the idea of disaster recovery. Oh, sorry. The idea of a disaster and being able to recover from it. And that's the second idea is if you have a fault that you can tolerate and keep going. Tolerate and keep going without having to worry about recovery. So fault tolerance is different from disaster recovery. That is something that I want to make sure that you are clear about, is that the idea behind a disaster striking and that you are able to recover it from the disaster at some point in time could be two different times. So for example, the time progression happens and disaster strikes. So disaster, and then at some point after the fact that you are able to recover from it. This recovery might happen after a certain amount of time, which is typically the downtime. Sometimes it is okay to accept some downtime, provided your customers don't get impacted or they don't notice. If they do not notice, or they don't worry about, they don't care, if you have a downtime, then it is probably okay to have some downtime, given customers are not impacted. If the customer impact is zero, you can have a downtime all day long, nobody cares. And that's the critical factor in understanding whether your business can tolerate downtime or not.
having some downtime might make things easy, might make it less expensive. But depending on customer situation, you may or may not want downtime. If the customers are okay and you don't care, it's okay to take downtime. Then nothing prevents you from doing that. However, many critical industries are not behaving, they don't behave like that. The customers are very, very critical about things going down. They will not tolerate downtime at all. They will not tolerate anything like this. For example, the bucket outage that we have today. And so if you have some downtime, then customers complain. And that is bad. That might lead to some loss of money, or money loss, data loss, money loss, reputation loss, and a bunch of other things, negative things come along when you have downtime like that. So in order to reduce downtime, or eventually find a situation that you completely eliminate downtime, you could, in certain cases, with some caveats. There is always a caveat that will, act of God, act of war, that might cause downtime. If something goes really, really bad, or meteor strikes, it might cause a downtime. And, that's a calamity happens. If it happens, then there will be downtime and probably there is no solution to it. If a meteor strikes and the entire continent disappears, boom, you have downtime. Can you tolerate that? I mean, you don't have a choice. Come on. So that's the practicality of it. There is always a statistical chance of something going bad that is beyond your control. And so this getting downtime to absolute perfect zero is theoretically not possible, because nobody can prevent, at least today, with given today's technology, nobody can prevent an eventual meteor strike. If it is going to happen, it is going to happen. And then you're screwed practically. So barring those situations that are very, 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 very rare, we talk about practical things, not about meteor striking. So just understand that, ideally, zero downtime is mathematically not possible, but we'll get close to zero. That's what we will try to accomplish. That's the practical goal, as opposed to mathematical zero, close to zero. Now, having that understood, in order to accomplish a zero downtime situation, you need to have basically a redundant configuration of every single thing that you do, which means that if you have a bucket here and that you put an object there and it is in the Virginia location, that you have another bucket with the same object in Oregon location, or some other location. You just have to have that. Or maybe some other cloud. Doesn't have to be Oregon. It can be the Google cloud as opposed to the Amazon cloud. And so you have two different clouds, putting your object in a bucket. And this is the Google bucket. You'll put the same object and keep it ready. Now, when you do that kind of a setup, you have to manage a couple of things. And I'll show you what I mean by that. For example, if you take this idea of creating an item in a bucket, so we'll go to the Amazon cloud and create this bucket we have, this bucket we have already. And we have this item there already, right? We can make it public, and then we can click on this item, and then that item opens up, and that's this item. So here is the link for it. There we go. Now, what if I want to have a highly available, highly fault-tolerant design to hold this object in that bucket? What would I do? What could I do? And so what I could do is something like this. Go to a different cloud. And in there, I log in, and then I create a bucket. So I have some storage here, apparently. So the not data store, but storage. Where is storage? There. So I go to the storage section, and there is this bucket I have. And the bucket, by the way, is already multi-regional. As you can see, the default storage class is multi-regional. So it's already spanning multiple regions. And what I'm trying to accomplish is that this bucket I have in the Google Cloud, there are no objects. So I'll upload a file and I'll say, you know what, this file, upload. The file goes up and it shows up right there. And it is available to me. I can make sure that I mark it as public. So I want to click this item and share it publicly. So the public link is available. And this is the public link that I want to be able to give you. So here is the other cloud, other bucket, same object, 2 different locations. You saw them, both of them. Now that is the action that you will begin doing, but there are some challenges that you have to worry about. And those challenges are basically translates to something like this. You have this URL and the other URL is slightly different. Let's go grab the other URL also, which is this one. And that URL is this URL here. So in the Google Cloud and in the AWS bucket and the Google bucket, they both carry the same object. The object is this. It's the same object. You see it. In here, the bucket name is different. The bucket name here is different. The cloud is different. This cloud is different. The object is same. That is one of the challenges that you will have when you want to span across 2 different cloud bucket providers. Like in this example, Amazon, in line number 7, and Google bucket, line number 11. And what does that really translate to? You can put all your eggs in multiple buckets in multiple different cloud companies, like this example shows you, but then this adds to complexity. What is that complexity? You have to somehow translate. If, say, for example, line number 7 goes down, so oops, it disappeared, not accessible anymore. You need to have a systematic method of translating this segment into this segment. So line number 7 should automatically translate to line number 13. And that translation doesn't happen magically. You have to actually write code to make it happen. You could do that. And if you have that need to have a really high availability situation where you cannot afford to lose this access to this object, you put that not only in 2 different buckets, but across 2 different clouds, like line number 7, line 13, same object, this object. And I'll just put it on top. The object is same. And essentially, you have to write code that gives you the ability to choose the appropriate link between line number 6 and 9 whenever there is a reference to an access to an object that is specified in line number 3. That is a new work item. No cloud company will give you this solution to let you put an item, line number 3, into 2 different cloud service providers because it goes against their business interest. It is not in the interest of Amazon to let you help you write code to let you put your item, which is this, into a bucket that belongs to Google. They're not interested. They will not help you, but you could do it yourself. That's the key to thinking about high availability. Is a simple example of making sure that this item is available across multiple clouds, not just multiple buckets, not just multiple regions. Like these guys claim these things, by the way. You'll see that this company claims that this bucket is a multi-regional bucket, and I don't dispute them. Don't dispute them at all. But the fact of life is that these guys also claim the same thing, S3. And you create a new bucket, and you can select that in a region here. But then you're limited to that region. They don't let you go span across multiple regions. So when you create a new bucket, so it's a new, excuse me. It's a new bucket here. They don't let you select multiple regions. You can select Mumbai, but then you're not in Singapore. You're in Mumbai. And so if a disaster strikes in Mumbai, you're screwed. Today, the disaster has struck in Virginia. And so anything that is in the new bucket that you will create here, this bucket, that you will run into an outage because Amazon has outage in the US East Northern Virginia region. And that is just unfortunate. That just happened. Now, what I suspect Google will come tomorrow and claim is this idea that we are not tied to one region. You'll probably expect to see this kind of a marketing game pretty soon coming from Google, saying that, you know what, don't be like Amazon does. Use our service, use our storage service. We are by default multi-regional. And you are very likely you will see some news or some analysis that says that and claims that. And the standard storage buckets are now listed as regional or multi-regional depending on their location settings. So you can learn more about it. You probably notice that Google must have already created this class of storage, multi-regional class of storage in a bucket. And what I am giving you an example like this is going beyond what either Google or Amazon could do. Is what you can, provided you have the ability to swap line number 10 with line number 15 on the fly. If you have the need to just suddenly go to a different bucket, this as opposed to line number 10, you could do that if you have that ability to swap on demand, for which you need to write code in your applications so that the customers who want to access this object automatically get routed to the one that is actually alive and kicking. And that will improve your overall availability of line number 7. Even if Amazon goes, boom. Even if it does, because you now have code that maps this line to line number 15. And so it will continue to become available. Your item in line number 7 will continue to become available to your customers even if Amazon is down. They will eventually come back. But who cares? I mean, even if they're down, you should not be able to, suffer from it. And this is the simple idea, which is about not putting your eggs in one basket. You just have 2 baskets. You will eventually run into this problem that the link is different. That is expected to be different. You just have to translate them accordingly on the fly and then map and write your applications to address the need of your customer to make sure that this object is highly, highly available, more than any one of these clouds can provide. And you can extend the same logic to any level of depth you want. For example, you could go to the Azure Blob Store, and in there, you could create a bucket and put that item in an Azure Blob Store bucket pretty much the same way, and you will get a different link here. Something like this. I'm just making stuff up, but you get the drift. The drift essentially is that every cloud provider will have its own way of addressing an item in a bucket. The bucket is under management of that cloud. If you want really, really, really high available, you will put that in 3 clouds in 3 different buckets, and then write your applications to address that need of really, really, really high availability by putting the same item in 3 different buckets across 3 independent implementations of storage by 3 top companies on the planet. You could do that, but bottom line, is there a need for that? That comes with a couple of cost elements. The cost comes from the fact that you have to now write code that has a URL different for Amazon. URL is different for Google, and that URL is also going to be very different for Microsoft. And so your code has to be changed. So that comes with a cost. The cost is to rewrite your app. That's a cost. It can be a major cost. This is probably a big cost. The other cost comes from the fact that you have 2 additional clouds. So you're paying them and paying them, as well as paying these guys. So you already have triple storage cost. And then on top, the cost of rewriting your application to address a scenario where you can put your object across 3 big companies. This cost is actually relatively small. It is relatively small because you know that the bucket cost of an item in a bucket from any of these top companies is pretty chump change. You know, the cost of storage is pretty low. I would say this is a small cost, but nevertheless, it is still non-zero. The real cost comes from coding, and nobody will help you in accomplishing this scenario unless you actually do it yourself. It is not in their business interest to help you accomplish this setup, but you could. Now that's the idea that I just briefly illustrated with 2 examples, and I did not show you a Microsoft example, but it works the same way. This is pushing the limits, really, really pushing the limits. Nobody does it like that. Probably 2 is good enough. If you have a really highly available, highly reputed service, you may want to consider something like this. But small companies, they just go boom. And then when Amazon goes down, they go basically blank. That's what happened today. Many big companies also went blank because of this situation, is that they put their eggs in this one bucket or one cloud service provider. And specifically those of customers that put that in US East 1, they were impacted today. So it is just a matter of time when other people will get impacted in other cloud locations, other region locations. It's only a matter of time when disaster will strike. Because what I can guarantee you is disaster will strike some point. And so that's the beginning of discussion around the idea of fault tolerance and high availability. The idea here essentially is that we have this end user, which is here. And this person is interfacing through a load balancer that spans across 2 availability zones, A and B. You have the same setup: web servers, application servers, database servers on the back end, some replication layer in between the 2, and the ability to fail over. The ability to fail over is basically being able to have this application server connect to either this database server or that database server here in number 2, provided if this fails, then you fail over to that one. That's the failover scenario they're trying to illustrate here. The application servers could fail over from one database to the other, depending on if there is an outage on one of those locations in one of those availability zones. And that's your left half of the design. What you will see in the illustration here is this other section, which is you have this thing indicating the idea of standby. So this idea of an application in standby mode basically involves another availability zone, A here, this A, where in that availability zone you have a set of machines running in standby and corresponding disk, EBS, which is the corresponding disk associated with this machine, is the elastic block storage, which is that box, the disk, hard disk associated with this unit, is the elastic block storage connected to this device, this instance is both on standby. The idea essentially is that you want to create your entire infrastructure and put that in standby, in a replica of existing infrastructure that you have. So here, the active application could be in, say, availability zone B, where you have an application running, sorry, here, this application running, and the mouse doesn't respond properly. So I hope you can see the mouse movement. This application is active, and it is interacting, this user interacting with your active application. And at some point, if you find that this particular active application doesn't actually respond to the user, you have the idea where your application is in standby mode on a different availability zone already. You could simply fail over. And excuse me. And when you do fail over, then this standby becomes active. And this active becomes, excuse me, this application that is active, it somehow starts to behave, starts to die, starts to not respond. And so you switch over to the standby location, mark that one as active, and then in the interim, the traffic for this end user will divert to the standby locations, which are now active. And the active that was active before is now dead or almost dying. And at that time, you will create a replacement. The idea of a replacement is to make sure that you are again highly available, so you at least have 2 of everything. So you're basically creating a setup where you are replicating whatever you had to begin with by replacing another set of services that you have on another availability zone, and replace the instance and reattach the disk. And that part, I think, deserves some clarification. So this segment that you have here in the right side is something that I would like to call out as to what that does, because we never actually experimented with that segment. And by the way, today is not a good day for experimentation because of outages in Amazon. So I'm very likely that if I run some live examples, they will likely fail, and I don't want to necessarily experiment right now. However, I will experiment next time. I hope by that time the outages go away. And so the scenario that I want to show you with this idea of replace instance and reattach volume. What does that mean, and how do you actually do it? That portion of this picture I will draw by hand to illustrate the idea in a white sheet of paper. So the scenario that they're trying to paint is that you have this customer that typically goes and interfaces with this active unit. This active unit has a hard disk internally, and that hard disk is what Amazon calls elastic block storage, EBS. This is basically disk. You can have like a 50 GB, 8 GB, whatever disk size you choose. That's the disk you receive, and they call it, Amazon calls it EBS. They also call it EBS volume, to be specific. It is basically the SSD that you will have in your machine. It is inside your machine, practically speaking, although logically speaking, although actually the disk may be outside somewhere else. So the fact that you have a disk and this runs your operating system and it is active and the customer is accessing it, and it in turn will access a bunch of other things on the back, and you will have a variety of implementations across the board, and all of these belong to one availability zone. Let's call it the availability zone A. And so what you intend to do is to have a backup plan, and that plan is to not about backing up, but actually about creating a live replica. It is running exactly like this one. So you will have exact same things set up and all the services that you will have running and live, but standby. And this is going to be standby. And by that, what happens is inside here, you will have a disk, and somehow you have to have a method that anything that you have here is actually a live replica of what is currently active. And everything else should be identical, practically, except this is standby, meaning The user doesn't go here. User could go here. It is live. So the users could, provided your DNS points them to that location. So this typically has an IP address. This typically has a different IP address. And so what you need to be able to do is, when you see that there is a potential problem coming up in your current active, this situation is currently active, but then it is causing you trouble. And so you notice that trouble, the customer will start to complain. Even before the customers complain, you might notice that this machine is not behaving properly through your monitoring that you have. So as soon as you monitor this, then you notice that this machine is not behaving properly. What you need to really do, provided you have an active standby, is just change your IP to this and then get rid of it. And when you change an IP, what happens? That this customer will just go here. And since it's a standby, you then mark it as active. Just simply calling it active basically means, use this IP address instead. So you basically change your A record change somewhere in your DNS and say that customers, please go here. And we have everything that we had here available here. And that is a failover scenario that might happen if this behaves improperly. And while it is taken down, you're basically shooting the whole thing because it's not behaving properly. While it is being taken down, the idea is to make sure that you take a backup of this thing. And then, or even either you can take a backup, or you can just disconnect the connection between this disk and the machine that you have and reuse the same volume, EBS volume, with another instance that you will provision. That's the picture that they're trying to illustrate here. They're saying, replace the failed instance and reattach the volume to a new replacement. That's the illustration in the picture. But what they're essentially doing, there's a chat message. The chat says, the question that you have in chat is, so is it a better idea to have a DR instance on another cloud and turn it on in case, even if one of those assets of one cloud provider isn't available, like what happened in S3 today, instead of taking a piecemeal approach of adding redundancy to each component? Yes, you're right. But let me tell you that it is expensive, really, really expensive, because you have to add code. Add code as in, you saw the example, a simple example I just showed you here. You had these guys, for example, you had Google and Microsoft. Each one of them has a different URL, by the way, here. And the way they engage with is a different set of API. So you might have an API that says Amazon API, AWS API. Here you have to use the Google API. So you have to basically rewrite your code to deal with multiple clouds. And that becomes expensive to do it that way, really, really expensive. And that is why you don't see much of this implementation at all. It becomes really expensive to go multi-cloud, multi-vendor cloud, really, really expensive. If you're going to associate yourself, you tend to go with one cloud. And that is a challenge that you have to make sure that you don't get married with a cloud provider. So you always write your applications that will work ideally in any cloud, but then sometimes there are limitations. So you have to understand and work around those limitations. So the question that you have here, I think there are good questions coming, so I'm going to read them again. So what Shiv is suggesting, is it a better idea to have a disaster recovery instance on another cloud? Yes, you could, but again, it involves a lot more code writing, which can be expensive. And if you have that kind of budget, you could do that. But not many people do it. Only very large companies actually tolerate that kind of a cost, and they'll implement themselves, by the way. If you are such a big company, you would want to have your own cloud, like Facebook does. They don't use anybody's cloud. They just run their own cloud in every location. They have their own Facebook cloud. And they don't have to worry about these cloud providers because they provide their own cloud and they have their own way of dealing with problems. And so they take care of it. And by doing it that way, you will reduce the cost aspects because you do it your way. And your way is consistent across any location, whether it is San Francisco or New Jersey or Virginia or Oregon or Australia. It is your way of doing things. So it applies to any cloud because it is your cloud. And that's, you don't even give that cloud service to anybody else, except like here you have Facebook. That's the Facebook cloud running it. And so this, what you see is what you see here. And here people are still commenting on my post about US Virginia region was semi-down, S3 completely out of service. So you see people are already commenting, but this cloud that you see, Facebook cloud, is not using Amazon, not using anybody else's. It is their own. And so they don't have the problem that you have when you are multi-vendor cloud. And that's the challenge, which is extra cost. It is very, very expensive, by the way, just so you know. That is why you don't see much of this. You don't see much of this, but I'm betting you will see new projects that will allow you, starting today, because of the disaster that happened today, like this happened today, starting today, you will see new projects that will facilitate multi-cloud bucket creations and multi-cloud implementation. That will happen eventually, but I'm just betting. I don't know. You could
So,
do that.
so that's where, can't we use the concept of containers there because they provide portability across multiple vendors?
I just heard you say containers. And yes, if you're in a container environment, you are simplifying your infrastructure a whole lot better.
True.
Because you are then not worried about this idiosyncrasy of a cloud provider. Like you see in this picture that they show you. Where is the picture? Here. Oh no, hold on. This picture. So you see that they're talking about reattach instance, reattach volume to the instance. You don't have to do these things if you do it in a neutral fashion. So if you're worrying about a specific instance that you want to restart, a replacement instance create and attach the volume that was used in a dead machine here, this active application that died, and you now have to detach that volume and then connect it to this machine, you could do that. This elastic block storage you have, EBS, you could disconnect the disk, connect it to another. That is possible. You could. And that scenario is useful, by the way. Every cloud will allow you to do this kind of setup. The challenges that you have in terms of code implementation is to deal with these boxes, the replacement box or the active box or the standby box. Every cloud provider will have their own method of generating these boxes. And if you are basically abstracting it away to create containers, you reduce some of the burden. And so more questions here. Why about creating a private cloud for the DR in your organization, but only keep it to the basic of basic going? And that is correct. That's how I think private clouds are structured in larger corporations that can afford private clouds. You would do that way, is have the bare minimum working functional in 2 locations, but mark one of them as standby and use one of them as active. And when disaster strikes, you flip the switch. And flipping of the switch should be automated to the extent you can. Okay, next question is, don't we need the instance active or at least consider data replication? Yes, you need at least one instance active, and the active instance should be the one that you have the DNS pointing to. So your DNS has to point to the currently active instance. If this instance was active before, but the DNS was going here, the machine starts behaving, then you break the DNS and you say, go here. And you keep that active, you mark that active, but it was a standby replica of the whole thing. You just fail over by changing some DNS entry here. And the customers would then not go here, instead go there. And that's the idea behind a hot standby that converts itself into an active. So this was a hot, meaning ready to go live anytime you demand. And it just changes from being a standby into an active on whenever there is a disaster here. And that's how you fail over. So that's the illustration that this, okay, there is more questions. So maybe limit the replication to weekly, bi-weekly, monthly to keep the cost down. Yes, but if you're doing replications on a weekly basis, there is a problem. The problem is like this. The problem is that if you have, say, for example, this is your active, and you say that you want to, in your standby, which is not hot, but it comes here like 7 days old. If you're doing a weekly replication, if it is 7 days old and you have a new disaster strikes, so you say disaster strikes, and then the user, instead of going here, the user will then go here. And if that happens, you have 7 days of data loss or old data, so stale data. So it should be continuously replicated. It should be actually a hot standby. If it is hot standby, then it is ready to take over. It is not 7 day old. It is not stale. It is fresh. And you can go bye-bye and make this active. And then the one that went bye-bye, you want to replace as a replacement. And that's the concept in that picture. And so therefore you want to keep hot standby for a good disaster recovery solution.
So Nilesh, does it basically just come down to you got to kind of weigh what cost outweighs how you want to replicate a DR environment as opposed to, jumping to multiple cloud environments, but kind of taking that risk of if this is going to go down?
Yeah, no, you're absolutely right. It boils down to cost. It boils down to what can your business tolerate, right? If you can tolerate a meteor strike, can you? I guess everybody will say, yeah, we have to tolerate because there is no choice. A meteor strikes a continent, the whole continent disappears. Can your business tolerate that? Is that even a valid question? I don't think so. It's a hypothetical question. It's a infinitesimal risk, and so it's very small. You can ignore that kind of a risk, practically speaking. So let's not leave that aside. Let's talk about practical. So when you're talking practical, the question to ask is, can my business tolerate the risk? What is the risk? The risk is what you have to really understand. And with that risk comes cost to address the risk. You could, address that risk in a variety of fashions. Cloud computing and high availability disaster recovery solutions are just one way to address the risk. There is a very simple way to address the risk of business. And that thing is called insurance, right? You just buy an insurance policy and you're done. What's the problem? Nothing. You can move on, right? It's a question of business risk. Can you tolerate the risk? Yes. Then go ahead and tolerate it. Just live with it. Can you not tolerate the risk? Can you provide some insurance policy? Either it is insurance policy as in actually go to an insurance company and have them give you an insurance policy. That's one way to do it, to cut the business risk. We are not talking technology at that moment. However, if you want talking technology, then you have to understand the cost to address the risk from a systematic technical perspective. We are not talking about insurance plans and buying and paying the insurance premium to address that risk, but instead find out a new solution that mitigates the risk. Mitigate the risk. Can this new solution mitigate the risk? If so, what is the cost of the solution? If you want to add a new solution and some kind of a new implementation you want to introduce in your company, that's a cost. Does it mitigate the risk? Yes, or maybe. If it is maybe, then the question comes, if it is maybe, because it's always a maybe, right? There's never a complete gone, the risk is completely gone. That never happens. There is always some risk. So what you're really doing in a mitigation situation is you reduce the risk. You cut that risk substantially sometimes, really, really nicely. But again, mathematically, risk is never zero. I'm talking math, and that is like meteor striking and all those stuff. So skip that. Practically, you can reduce the risk. Now, with this reduced risk, you will ask the same question again. The question is, go back on the top. Can your business tolerate the new reduced risk? And if the answer is yes, then you shut up and tolerate. If the answer is no, then you come up with another plan, another solution, another improved solution. And this improved solution will become even more expensive and even further reduce the risk. And it's an iterative question that you have to keep asking as your business situation changes. The question to ask is, can my business tolerate the reduced risk or even further reduced risk? And if that's the case, you feel happy about spending this money, add another improved solution, and be really, really happy about even further reduced risk. But remember, this is not zero. Mathematically speaking, there is always a risk. And you can keep going in loops, in circles, until a point where you feel that the cost of addressing the risk is way too much to reduce this already low risk you have. You want to go even lower? It might cost you an arm and a leg apart from the dollar. And so are you willing to spend this to go even lower? I bet not. At some point, you will draw a line and say, okay, enough. I'm willing to live with that risk. And that is the fundamental question to ask in case of disaster recovery, fault tolerance, high availability. All these things boil down to this one question. Can my business tolerate the risk? What is the risk? How much does it cost me? The risk itself, right? Risk actually translates to business loss. So when you have a risk, it translates to loss to business. Lost business. That's what it boils down to, loss of business. So the question is, can I tolerate that loss? If so, yes, I feel happy about not doing anything. Why bother? If I cannot tolerate that loss, then I have to reduce the risk. To reduce risk, I have to put a mitigation plan. And so this loss, let's say this loss is $1, right? That's the loss, I will say. So I want to reduce, I want to put a mitigation plan. And this mitigation plan will cost me $1 and will substantially reduce the loss or the risk. It will go down as a consequence of this reduction in risk by putting a mitigation plan in place, which costs me $1, which is better than this. So I will say, yeah, it makes sense. Let us do the mitigation plan because it reduces the risk. And so the new risk is lower risk. That leads to a loss of business, which is only $, as opposed to $. So reduce the risk, the loss of business, potential loss to business as a consequence of a lower risk has gone down and you feel happy about it. But again, the same question. Can my business tolerate a dollar risk? And if that answer is no, I cannot tolerate that loss if it happens. So you put another plan. Reduce even further. Put a mitigation plan in place and spend dollar. Right? It's going to be even more expensive because you want to cut the risk, right? So mitigation plan comes into place and it will say, you know what, you can further reduce the risk and the loss to business will be only $1. Nice. But is that really nice? What about this? The mitigation plan costs you like $3, three-digit dollars already. Is that a good idea? No. I would not spend this kind of an idiotic money because the benefit that I receive is too small, only one digit from dollar to only $1. I mean, not single digit dollar. Whereas the mitigation plan to accomplish even further reduction of risk cost me like a boatload, and I can go down further like this. But at some point, you're noticing this is called diminishing returns. Diminishing returns. And let us do a search on this word. This concept is, so the question was, that is my default question. What if I cannot survive an asteroid strike? I don't want, and let me read the question again. So it says, that is my default question. If I cannot survive a asteroid strike, I don't want it. Yeah, exactly. You may not want, because you know what, if an asteroid strikes, meteor strikes, everybody's gone. Why do you even care about your business? Just move on, go to another world or something. I don't know what happens after that, but just, it's a hypothetical question. The question that we should really think about is that cutoff line. So there's this, the cost of fixing something and the risk going down, it crosses at some point, right? This is the cost to mitigate risk and the potential risk. Risk goes down as you implement more new solutions, and the risk goes down like that. And you keep spending more on new initiatives to further reduce the risk, but at some point it will cross over. And at crossover, there is no point going in this direction at all. In fact, there's no point even going here. Just stop right here. And that's a good way to think about mitigation plans, disaster recovery, and the law of diminishing returns. So law of diminishing returns is like this. So let's go read that. It says in economics, diminishing returns is the decrease in the marginal output of a production process. As you can read, the concept is this picture I just showed you. I just draw this picture for you, and at some point, like you can increase the inflation and unemployment rate. This is economic stuff. We don't want to necessarily go and talk economics right now, but you get the idea. The idea is basically this, which is at some point you stop making further disaster recovery plans because it doesn't financially make sense. Okay, now let's get back to remaining questions if you have any there. So I think those are answered. If not, keep asking the questions. Don't stop asking questions. Keep going. If you have any doubt in mind, clear that, because I think that helps you in getting that clarity about, because people talk about disaster recovery all day long and do this and do that, and it's all exotic. You have exotic as in you can keep going and improving upon something, on some plan to do it this way versus that way, and all of it translates to some kind of a cost benefit analysis, which you have to make a decision. Do you want to do that or no? Stop. Because the diminishing returns, the benefit of reducing that risk further outweighs the reduction in risk. That's how you should think about any disaster recovery plans. So that is what I wanted to say. And I hope that answers the questions that you have up until now. So let's go skip ahead to another illustration that we have here. And let's go next, cancel, and AWS architecture. And so here is Architecture Center. We will go look at another example. And that example will be, so yeah, many of you use this thing called Dropbox, right? I suspect you use this Dropbox application. Pretty popular for people to be able to share and you know what Dropbox is. I don't need to tell you what it is. I'm assuming you know. So with that assumption, that is what this illustration tends to indicate. So click, and I will give you a link, and you can see what this thing basically does. So let's go see that in Slack chat. Paste the link here, and that file I will open up right now. And it is slightly different from Dropbox in a sense that I will describe. And so the idea that in this illustration that I am going to open for you, which is the link that I have, which is RA file sync PDF, which is in this location, RA file sync. Which one is that? This one. Let me open that file. And in here, the illustrations are talking about something like Dropbox implemented on Amazon. I must tell you that Amazon does not currently host Dropbox anymore. They used to be on Amazon Cloud. They have gone away. They have become big. So Dropbox migrated away from Amazon. And there is a case study on that. You can read if you like, but at least the story is like this. The epic story of Dropbox exodus from the Amazon cloud empire. So they press writes it in a flowery language. Essentially, Dropbox walked away from Amazon's cloud. Why did they go away? Is something that is obvious. They have gone big. When you grow big, you need your own cloud. That's what they did effectively. They created their own cloud. So Dropbox is showing why the cloud is powerful. It too is building infrastructure so that others don't have to. Bottom line is Dropbox now has its own cloud. And like this own cloud is actually an open source project which clones Dropbox. And so this is own cloud, and it's an open source Dropbox. You can download it here and go to GitHub and all that good stuff. But it's conceptually open source Dropbox solution that you can run it in your own cloud if you like. Now you know what Dropbox is, so I will go and talk about it in this illustration, which is coming up here. Oh, here. And so in this example, I just want to make sure that you actually know what Dropbox is. And if you do not, please tell me that you don't. So I'll explain that. I'm assuming that you do. And so what Dropbox does is to allow everybody to store stuff in the cloud. Simple. And also allows people to share their stuff with other people. And so in the illustration that you have, there is this concept of a file followers here. This idea here, file followers. What does that mean? And who are these people? And that is something that I think is a good example, will be good. So I'm going to open my Dropbox application and show you this idea that I talk about. If you do not know what a file follower is, I think you should say that, so I can explain to you. I think it's worth explaining what a file follower would be in the context of the picture that they're trying to draw. So let me see, where is my Dropbox implementation? Here somewhere. Yeah, that is Dropbox. And you will find that I have this Dropbox, and I'm going to see if I can open it. Okay, come on, open Dropbox. So here we go. Open No. That's not what I want. So I'll open it locally. So the Dropbox sits here. So there is this Dropbox. And I have a bunch of things in there. Now what I want to be able to do is put an object in the box. As simple as that. So I'll go and pick up a picture of some sorts, or maybe one of those PDF files here. And these PDF files, I want to put that in the box. So I'll just take it from here and put it in my Dropbox. What did I just do? I put that file here, and it is now in my Dropbox folder. What is going on under the hood? You will see that this file, AWS AC RA FTHA 04 PDF file, is now in my Dropbox. What does that mean? If I copy the link and open it up in the folder, that opens up right there. If I go log into Amazon in a browser and go to dropbox.com, okay, come on, dropbox.com, and here I need to log in to show you the item that I just posted, and I will now make you a follower to my file. So you will become a file follower. How do you become a file follower? Because I will make you one. What does a file follower do? That's what I will illustrate. So it's basically a person who is receiving my file, who is tracking my file, who is following my file, and I'm just getting a token from here. And that token, I will copy and give it to the browser so I can go inside and submit. So now I'm entering my Dropbox, and you will see that in my Dropbox, I have this this file that I just added, which is uploaded. Recent uploaded file is this file. So I can see that I can share it. Like click and share with you. So I can just, anyone with a link, so I show the link and I grab that link, copy and give it to you in Slack chat here. So now you can access the same file just like that, provided you have that link, and you now have. So you should be able to access that same object that I have put in my Dropbox just like that. This file that you see is now available in that location in my Dropbox, and you can see it. And that's what I just did. So you become a file follower as a consequence. Now, if you go look at this picture again, you will see that these people are followers of a file that the creator has decided to share. Now, that's the usage of a file follower picture. Now, what that file followers do is receive an email message from an email sender service that basically advises them that they now have access to the file that they were following, that they were looking to receive. And that email message you might receive if I decide to use that route of sending you a link to follow the file that I gave you. You could do that in Dropbox service. You can actually assign. I just made a shortcut and pasted in Slack chat like this. But the proper way, the Dropbox recommended way of sharing a file is not this, but instead you assign somebody like Raj, Kola Gotla, and then have them share. So you have to click and share that particular file, this file, with that person. And when you share, Raj is going to receive an email. That is what this picture is illustrating, is that there has to be a service on the back end inside this cloud. They have a service called SES. And that service is an email sending service, basically simple email service. What it does is sends emails. It will send an email or notification to Raj, provided I click that button, specifically this button, the share button. And when it happens, the application on the back end will detect that this person, Raj, becomes a file follower, and that will need to receive an email with a link to that file through the Amazon's simple email service. It is a service, by the way, available here in Amazon's cloud. You can see that. Where is Amazon's cloud? Here. So you can go and find out about simple email service. And so there is one of those services. There are so many of these guys. So here, SES, simple email service. And what you can do here is to you enable this service. And I don't use this service, by the way, but I have attempted to configure it already. So the domains are listed. Now, don't have any verified domains, apparently. I don't have any, so I've never used it. So before you start to use that service, you have to tell which domain and which email address will you use to send an email out. Maybe I did it in Oregon. Yeah, that's where I did it last time, if I remember. So I have the ability to send out emails from these addresses. And these are the addresses that have the ability. So hello at CloudGenius, Nilesh at CloudGenius, team at CloudGenius, 3 addresses that have been verified to be owned by me, have the ability to send out email notifications if I configure it and program it the way I would like SES to work. And that is simple email service. And I have done it in the Oregon region, apparently, where I have added a domain. And so my domain shows up here. That is this domain. It has been verified with the TXT record and DKIM record and a bunch of other things. So that's what you need to do in order for you to use that SES service, which is what this service will do, is send email notifications to the file followers. Now, back in here, when you have a new user that logs on to your service, you need to have that user upload something. So for example, I uploaded a new item. When I am uploading a new item, what I'm basically doing is running that client software, which is the Dropbox application here that you can see. This application that you have, it has a login to my account, and I have a quota, 27 gigabytes of usage, available, 51% used. And my location where I have currently stored the item is in a hard disk, which is this location. I could change my current location, the local location, but a replica of the whole thing is stored in the cloud. And that's what you see. This is the client application that transparently interfaces with the cloud service using this email address and is able to send and receive and synchronize files stored in that folder. Which folder? The Dropbox folder on my local machine. So here is the local machine, and I have the Dropbox folder. And in there, I just added this file, and that got synchronized with the cloud. So what you see is it shows up here, and I can basically delete it from there if I want to. And if I delete that, it will disappear from my local computer as well. You will see that it disappears from my Finder, and that file from my Dropbox is gone. It disappeared already. It's not there anymore. It is able to synchronize, and that feature you saw enabled is actually functioning like this. So you have a machine that is this desktop, for example, or the same application, Dropbox application on a phone like this, or a desktop like this. That applications that run here or here are basically looking up the correct DNS entries. The application is doing the client application, which is this Dropbox application, is what did I do? No, load mode upgrade. That client application, which is this application, is connecting to this account here and is able to find the DNS entry for the Dropbox services, go to the appropriate application servers through the load balancer. So when you have a new item added to the Dropbox folder, this desktop machine or this iPhone application will actually send that file to the S3 bucket. After it gets an approval to send, the approval has to come from the application server. And that application server you can access through a load balancer. So you have to first go authenticate yourself, prove that you are indeed the person you claim to be. That will generate a token. You take that token and then have that object that you want to send, this object, the PDF file, or anything else that you have in the phone or the desktop, gets pushed to a bucket. and that gets to sit here. And so here is your Dropbox collection of objects that you will store in a repository in some storage. That's where it will sit until you decide to do something with it. It will also synchronize, meaning if something changes here in the cloud, it will automatically go through the synchronization process between the bucket that you have in that location, S3, and the current folder you have where you have that particular desktop storing your local content of Dropbox, such as, where is that thing?
The next question.
Yes.
So the file synchronized service which you showed, is it an added component to the interface service, or is it something which we program and configure and could ask?
Hey, can you describe added component to what?
Just like a PHP service or Ubuntu server, is the replication a component which we put
Is replication a component of what?
Amazon?
No. Dropbox application is doing the replication. So you have, let's see here. So this application that you see in the Dropbox app, it is going to automatically look for changes in the file system. So for example, here in my file system, I will see if I add a new file. So I'll say right click and new folder, click. And I added a new folder called untitled folder, and I click to save. The folder gets created here. Nice. Now what? What just happened? I see this green box, this green check box. What does that indicate? That this particular process that is running in the Dropbox application, specifically, if you see the activity manager, you have the Dropbox application running here, one of those guys, which is Dropbox. And so this Dropbox application is actually responsible for synchronizing a change in the file system here and sending it over to the cloud. So you should be able to see a folder called untitled folder in my web browser when I visit that particular location. So we should be able to visit that. We'll just go to Safari browser, and in there you will see that recent items. There is a new folder called untitled folder showed up, and it showed up because I created it, not in the cloud. I created it locally in my Finder here. I created an untitled folder right there, and it showed up in the Dropbox website just like that. Now just watch it. This untitled folder will disappear if I delete from here. I will delete, right click and move to trash. The folder goes away, and now what I will do is see that I do nothing else except wait and watch. This particular process, the Dropbox process, is actually active. You can see 42% CPU, and it will eventually go down as soon as the synchronization finishes. And you will see that when I go refresh the browser, that this untitled folder goes away, it disappears. So you see that when I refresh, it is gone. So the recent items, it has disappeared, by the way. Not only that, it also gives you the ability to recover. And so it puts in the trash can right there. And you can actually go back and look up a file that you accidentally delete for 30 days. For example, this file, the PDF file that I have accidentally actually by design deleted, I want to restore it. So I could restore it back. And as a consequence of that restoration, you will see that the file will show up right here. As soon as I say this file, as soon as I say that I want to restore that file, so click, and you will see that the cloud restores it. And so I restored, and on the left half, you see that the PDF file showed up right there. This came because of this service that is running, that is synchronizing between your bucket in the cloud. I mean, it's not Amazon anymore. It used to be Amazon, not anymore. And your folder in your desktop. So this is the folder that I have, which I keep a bunch of stuff. And most of it is my private stuff. But then I could decide to share a particular item with anybody I like. And I could, and I did share that one item. So you could decide that I'm sharing certain items with other people. So here are the people I share it with. And they share their folders with me. And basically, the family member sharing pictures. And so we do that. And when I want to give somebody something, I just put that in my Dropbox in a shared folder, and it just goes there. That replication is happening in the background because of this process that runs all the time. All the time, it is running like a 0.4, very low CPU consumption. But if you try to add something or delete something, like for example, let's say go back to recent, and you want to now delete this item one more time. So delete. And I'll say yes. And you watch the CPU consumption on the Dropbox process. Watch that one. So I'm going to delete it. And it goes click, click. So it's gone. You will see that the CPU consumption goes a little bit higher. It's only required to delete the item locally. So it is not too much tax on the CPU. And it deleted probably by now. So the thing is gone. I can go back here, bring it up again and say files, recent, deleted items. I want that thing back, please. So I can bring it back. That's the synchronization happening in the background. So I can say bring it back, and it comes back, and here it comes, shows up right there. And the Dropbox process is a little bit higher than usual. Usually it is like 0.5, it was 5 CPU consumption. So it's a very efficiently done application. This is the person, this is the service that runs in the background that is responsible for synchronization between this folder and my Dropbox account, which actually is a bucket. Not in Amazon anymore, but it's a bucket of some sorts somewhere in the Dropbox cloud these days. They have migrated away from it, away from Amazon. So that's this synchronization service from an actual usage perspective. Let us see what the picture, other elements in the picture describe. So the idea here is when you share a file with a file follower, they need to get what is known as a security token. Otherwise, they can just share that link with anybody, and you don't want that. You want to secure sharing with appropriate people that are authorized to receive that particular item that you want to give. So this one of these files that you have here, which is in your repository, you want to share it with appropriate people, the file followers, and you want to give them a secure token that you can generate with another service that Amazon has called Secure Token Service. So let's go see what that service is. So back here in Amazon's console, let's see if there is a STS service here somewhere. There should be one. And so STS, where is that? They have so many of these guys. It's hiding from me. But let's see, token or STS. No, apparently they don't show it like this. They may be using some other name. In the picture, they're using AWS STS. What is the name that they use commercially? AWS STS. Secure token service, documentation, actions, sign into console to show me STS, and I cannot find it apparently immediately. So there must be some service that either I don't have access to it or it is new or something, but I don't think it is new though. I've seen it before, but I don't seem to be able to locate that service called Secure Token Service in this cloud for me in Amazon. I don't know if you see it or not, but by the way, let me tell you, you don't need to rely on Amazon's token service implementation because you can generate your own tokens. If you write your applications and have the application servers create a token for you, you don't necessarily need to use that token service. It is there for you if you want, but don't have to use it. If you decide to write your own code, you deal with it here. And that will generate a secure token that will basically authenticate a file follower for checking its permissions, whether you have the appropriate token or not. And if they carry that token that allows them to access that particular file, they can also, on their desktops, like here, connect to the same file repository using the token that they have and access the same object and synchronize, and that they can continue to work on it. Now, all these objects that you store in a variety of buckets, you need to store the information about those objects, information about what you have kept in the bucket. It is easier to keep track of what you have in the bucket and what was not there anymore and all that. The data about the data is stored in a database. Data about the data is metadata, and that is what is stored in this location. File metadata. And this is a data store. It is not your relational database service, RDS, but it is like Mongo database or NoSQL database. It is the Amazon's implementation of Mongo-like database called DynamoDB. Again, you don't have to use a DynamoDB. You could use Mongo if you like. If you want to use your own Mongo database, you will just have to have a bunch of servers, run Mongo, and not use this service. It's a question of choice. Do you want to use that ready-made service that you have, or you want to use your own Mongo database and run it on a set of machines like this? You could do that. Your choice. Next question. Is Dropbox better implemented than Google Drive? I don't think so. Is Google Drive better than Dropbox? I don't think so. It's a question of I have never had trouble with any of these two services yet. I should say yet, because trouble will happen eventually. But yet, I have not had. I must admit that I have had trouble with OneDrive, which used to be called SkyDrive and LiveDrive and all those Microsofty names. They have had trouble with the implementation. But these days, SkyDrive, OneDrive seems to be okay. Raj says avoid OneDrive. Yeah, you can avoid if you don't like it, but sometimes I must call out that all of you, if I did not give you access, let me tell you, all of you have access to unlimited storage from Google Drive as a part of Cloud Genius. You are a student at Cloud Genius. It gives you access to unlimited storage space in Google Drive if you decide to use it. You have to ask me for your Cloud Genius email address that you may or may not have. I think we should make you stop talking. Is it timeout or what? I think we went ahead. So yes. Yes, Raj. So bottom line, I think Charles Griswold and the other person, I'm forgetting his name, he's here. Let's see what is, the guy from East Coast, those two guys. You do not have a Cloud Genius email. If you're interested, please tell me. And what happens as a consequence is that you get unlimited storage for no other reason. And this is probably for life, by the way. I just want you to know that this gives you unlimited storage space. For everybody at Cloud Genius gets unlimited storage. If you want it, you get it, as long as Google decides to keep giving it to you. I don't control it, Google does. You have to have this email address. If you are interested, please let me know. And in that case, you can use. And unlimited means unlimited, practically. There's no limit. Having said that, let's read some more questions. But Shiv says that's what companies are implementing. That means what? What are they implementing? OneDrive. Yeah, if you get Office subscription, you get OneDrive to begin with. They just give you, and there's two variations to OneDrive. One of them is OneDrive has these two implementations. One of them is a consumer implementation. The other one is an enterprise implementation. They have different names for it. The enterprise implementation is called OneDrive for Business. I think that's the name. And this one is called OneDrive. Let's go see the names from outside. The names are OneDrive for Business is one application. And then the other one is called just OneDrive. And so I think they're merging these two things together to form one solution. So you can go to onedrive.com. Should take you there, I hope. And yes. So here we can sign in and then use our Office 365 subscription, and you should be able to access your OneDrive for Business. And there we go. So I'm going to sign in right now like that and provide a token to access, and token approval is coming. Don't ask for 60 days. Where's the token? Come on, token. Approve. So I just approved myself. So I will now go to access the OneDrive backend. I don't have OneDrive locally installed because I don't use it much, but it is there. And that's pretty much the brief discussion on OneDrive and drives. So we'll continue our discussion next time. We will meet again on 2nd at 4 o'clock, which is Seattle time, 4 o'clock. And then it translates to 7 o'clock Eastern time on Thursday, 2nd of February at 4 p.m. Pacific, 7 p.m. Eastern. That's when I will see you again. In the meanwhile, I would like you to read. What I would like you to read is this specific. There are lots of interesting ideas and implementations available from Microsoft. They are also good. I would like you to read this segment, and I will go over it. But the problem is we might run out of time covering each and every one of them. So I'm basically making sure that all the important implementations that are common in enterprise applications is what I intend to cover. If you want us to cover something specific, please call it out. But on your own, please read this. And if we have more time, we will cover these things. And we'll also do some exercises. But today was not a good day to run exercises live because of outage. And so we will run it sometime, maybe next time or even after that. There are exercises that we have to do. So I'll either do it on Thursday or Saturday or one of those days. And we will implement a VPC, VPC solution through automation. That is something I want to do. I want to be able to do and also cover aspects of Docker Swarm and Kubernetes. Those two things are new. They're really, really useful. I think many of your companies are probably playing with either Kubernetes or Docker Swarm or both. You should study that, and I will help you with live examples. And you can run them on a cloud of your choice. And we will play real exercises with those things as we go along. So thank you guys for listening to my cough today, and I'll see you Thursday.
Take care, Nilesh.
Bye-bye.
Good night.
Bye, Nilesh.
Bye-bye.